Okay, so I'm getting ready to do the reaction in part 3 here, where I need to measure out 65 milliliters of my calcium chloride solution, this 0.4 calcium chloride solution. So I'm going to use my graduate cylinder here to measure, where I'm going to pour it in here. Once again, I got to get down and see the meniscus. Right at 65. Okay, so I'm going to bend over and check it. Okay, it's slightly below, so at this point I'm just going to add a little bit more, being very careful to add it slowly so that I don't go over a few drops. Let me check it again. It's still slightly below, so like 1 or 2 more drops should do it. And then I should be okay. Don't go too far over. Oops, that probably went over. Let me see. Oh no, actually that's pretty good. Looking at the bottom of the meniscus, yeah, that's pretty exact. All right, so 65 milliliters of the calcium chloride, the 0.4. Here's my A sample. It's all nice and dissolved in its beaker. So all I have to do now is add this and stir for 30 seconds. And then I'll be setting up my filtration. Oh, look at that. Look at that nice white precipitate coming out. So I stir for about 30 seconds. Make sure everything gets reacted. And then I have to let it settle before I start filtering. So I'm gonna keep stirring for like 30 seconds. I'm not gonna make you watch that, but just know that I'm stirring here to make sure everything's reacted. Okay, before I can continue, I need to find the mass of my filter paper. So I'm going to label them A, B, and C for the different samples. So this is going to be a mass of the filter paper for A. So you can see here, I'm going to let that stabilize, and then we will write down 1.2153. And I'm going to do the same thing for the B and the C. That's adjusted a little bit, so let that stabilize and go with that. So I have all the filter paper data in my data table. All right, so stabilizing at 4.6. Okay, so here's our setup for the filtration. We have our funnel, our clay triangle, the iron ring, the ring stand holding up the 250 milliliter Erlenmeyer flask here. Now I'm going to take the paper that I just measured the mass of for A, and you need to fold it in half. Then you fold it into quarters, and then after you've done that, you can pull 3 of them to one side, and it ends up looking like a cone shape that will fit into the funnel. Now, in order to get it to stick to the funnel, I'm going to just put a little bit of water in here so that it stays nicely. So when I'm ready to start pouring my A in there, now I let it settle for a little while. As you can see, some of the precipitate fell to the bottom, and you can see that nice layer of precipitate at the bottom. Put my hand on the back of the flask here, or the beaker here. So you can see it's still a little cloudy in some of the liquid, but what we're gonna do is we're going to filter the liquid first, and then when it gets down to almost being near that layer, we're gonna swirl it around and keep filtering. Now when you filter, you don't want it to go above the filter paper in the funnel, but you'll see here, so I'm pouring it in, I'm almost to the top of the filter paper, and now it's coming out pretty fast. It should, because it's liquid, but as you can see at the top of the filter paper here, you don't want the liquid to go above it. So that's what I'm going to keep doing, is I'm going to keep adding more to the funnel as it clears through, as it starts to go down. This process is very time consuming. It takes a long time to do this. So I'm just going to keep adding. And then when I get to the precipitate layer at the bottom and I have to swirl, I'm going to show you that step. So right now it's really just filtering most of the liquid. A little bit of residue from the liquid will stay on the filter paper, but for the most part, we're just getting rid of the filtrate, or the liquid part, and we're going to keep the precipitate on the filter paper. Okay, now as you can see, we're down to our little bit at the bottom here of the precipitate. So I'm going to swirl that really good, use this so it becomes nice and milky white. Then I'm going to filter the rest of that in there. Pour that in there. Now, of course, some of the residue is going to stay in the beaker, so I do need to wash the beaker a few times and also filter that because we want to make sure we transfer all of it into our funnel. I'll even rinse off the stirring rod here, make sure that's transferring, and swirl that around, pour that in there. Okay, do that a couple more times. Mixing out the beaker, making sure we're getting all of it to go in to the filtrate. And now the beaker looks pretty clean. One more time, one more rinse, and we're ready to go. Okay, so I'm not sure you can see, but the white precipitate is now on the paper there. So what I'm going to need to do is wash it a few times and make sure that there's no residue that's sticking on there that shouldn't be on there. So I'm going to take my wash bottle and just rinse the filter paper, rinse all the white stuff like 2 or 3 times. I'm going to do this for all of the samples. So again, we want to make sure that we're only collecting the calcium carbonate. So we're going to wash it a few times and let that keep filtering. And then I'm going to take my filter paper and put it on a watch glass and put it in the oven to dry. So we're gonna, and then I have to come back tomorrow to actually find the mass of the filter paper with the precipitate all dried out on it. So that's pretty much the setup. It's a time-consuming lab, definitely, because it takes a long time to filter. So you can see it going on. I'm gonna wash it 2 more times. I'm gonna do B and C as well, exactly the same way. Put them all in the watch glasses to dry overnight, and then be able to come and check out the mass on the next day. Okay, so here is the heating oven that we're going to use to dry out the precipitate a little bit, and then poke through it and let it sit overnight so that we can I can come back tomorrow and measure the mass on it. So for our sample A here, what I'm going to basically do is take the filter paper out gently, place it here on the watch glass. As you can see, I placed it on the watch glass. Now I'm going to separate it out and expand it so that it's flat on the watch glass. Hopefully I can do this with one hand because I'm trying to video with the other. And there we have our precipitate. Now, what we're going to do here is I'm going to stick it in the drying oven for about 20 minutes, and then I'm going to poke through it and make sure that it's not clumping, and it's going to dry thoroughly out so that there isn't moisture still left in the middle clumps. I'm going to do the same procedure for B and C as well, and then tomorrow I'll come back and measure their mass of the precipitate on the filter paper. Okay, so before we can find the mass, we will need to break it up. It's been drying out for a little while. Break up the precipitate using the stirring rod or some other, I guess you could use a spatula to break it up in little pieces. Make sure that it's completely dry out. I'm gonna let it dry a little bit more, and then we will find the mass afterwards. So you have to break it up in little pieces. We'll put it back in the oven, let it dry out some more, and then we will find the mass. Okay, so here, finding the mass of the filter paper plus the sample. Here's for sample A. We'll place it out here, find the mass. Okay, and then we will use that value to calculate our molar mass in the end. You'll need this value through some calculations to be able to figure that out.